Good morning, IB Math. All right, what we're going to look at next is 6G and 6H. I'm going to do them both as individual lessons, but both of them look at some advanced trigonometric ratios. We already know the basic ones: sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; tangent, opposite over adjacent. But those trigonometric identities only work in right triangles. Well, what if we have a triangle that is not a nice, well-behaved right triangle? How do we deal with it? Well, there's two different ways: law of cosines and law of sines. So in 6G, we're going to look at the law of cosines. Now, the law of cosines deals with a non-right triangle. So I'm going to try to draw a triangle that doesn't have any right angles in here. And what I need to know is it deals with an angle and then the sides of a triangle. And if any one of these things is missing, I can use law of cosines to find the other three. There's really three variations of the law of cosines. Let's take a look at each of the three variations. So in the first variation, suppose I've got, this is angle A, and then side lowercase a is across from angle A, and then B and C. What it tells me is that the side opposite from the angle squared is equal to the other side's, the sum of the other side squared minus 2 times BC times the cosine of the angle. Another variation of this is, suppose I say AC, little b, little c, and this time angle B. Well, the side opposite from it, b squared, is going to be a squared plus c squared minus 2ac cosine b. And of course, the third variation here says if I have, and again, I'm trying to draw triangles that are not right triangles, and I have sides A, B, and C, and this side angle C, then c squared, the side opposite, is going to equal a squared plus b squared minus 2ab cosine angle C. So the capital C is the angle, the capitals are the angles, the lowercase are the lengths of the sides opposite from them. All right, let's see how this works. Let's look at a sample problem now. Let's draw a triangle. Oh, by the way, there's a proof for this. There's a copy of a proof for this in your textbook. You might want to look over it on page 391. Suppose I have a triangle, and I've got sides of 9, 11, and 16. First, remember from geometry, we can check to see if this is really a triangle. Do the two smaller sides add up to be bigger than the other side? Yes. So Pythagorean inequality tells me that that triangle really does exist. And I could find any one of these angles. If I wanted to find, for example, the smallest angle, well, the smallest angle would be across from the smallest side. That would be the smallest angle. If I wanted to find the biggest angle would be across from the biggest side. That would be the biggest angle right there. But I want to find that angle right there. So let's find theta. Find that angle right there. All right. Well, my law of cosines says that the side opposite from the angle, the 11 squared, is equal to the sum of the squares of the other two sides minus 2 times 9 times 16 times the cosine of alpha. Oh, running out of paper over there. All right, so let's simplify here a little bit. 11 squared, 121, equals 81 plus 16 times 16, 256, minus 2 times 9 is 18, times 16 is what, 288, I think, cosine alpha. I need the calculator at this point now. All right, so here we go. So let's see. So let's start with that 121 minus the 81 minus the 256, and I get negative 216 equals negative 288 times the cosine of alpha. Divide both sides. by negative 288 divided by negative 288, and I get 0.75. Now take the arc cosine, the inverse cosine of both sides. And I get alpha is, so inverse cosine of my answer, 0.7227. Now, does that make sense? What mode am I in? Let's see, I'm in radian mode, so that would be the answer in radians, between 0 and 2 pi. What would be the answer in degrees? Well, I'm going to go change to degree mode, and then I'm going to do the same calculation. What is the inverse cosine of 0.75? And I get 41.4 degrees. So this would be in radians, and this is in degrees. Of course, I also could have multiplied this by 180 over pi, couldn't I? Just regular conversion. All right, let's take a look at another one. So that one was finding a missing angle. Now let's do one where we have to find a missing side. So again, I'm going to try to draw a non-right triangle. And here I'm going to tell you, let's say that this is 26 degrees. And I'm going to tell you that this side is 11 and this side is 8. And I want to find that missing side right there. All right, this is a perfect one for law of cosines. As I take a look at this, I know that the side opposite from my angle, x squared, is the sum of the squares of the two sides adjacent minus 2 times 8 times 11, I'm running out of space again, times the cosine of 26 degrees, squeezing it in there. X squared equals 64 plus 121 minus 88 times 2. 88 times 2, make sure I got that right. Whoops. 88 times 2, yeah, there we go. 176 times the cosine of 26. So x squared equals 64 plus 121, 185 minus 176 times the cosine of 26. And really, x is going to equal the square root of whatever that is. 185 minus 176 times the cosine of 26. X is equal to, that's degrees. I want to make sure I'm in degree mode. Okay, I'm in degree mode. Okay, good. And then I'm going to do the square root of 185 minus 176 times the cosine of 26. And that missing side over there is 5.178 units. If this was centimeters and centimeters, this would be centimeters. All right, so there it is, law of cosines, and the two different variations of law of cosines. Now, you're going to see ones where it's pretty much straightforward, and other ones, don't get hung up on the ones where it says a triangle is in a specific ratio of like 2 to 5 to 6. Well, if that's the case, just put down, if I have a triangle that's in the ratio of 2 to 5 to 6, well, that's just going to give me a triangle of 2, 5, and 6. And then, what am I looking for? I want to find the smallest angle. Well, this would be the smallest angle across from the smallest side. The biggest angle. Well, that would be the biggest angle across from the biggest side. Okay. If it's in the ratio of 2 to 5 to 6, does it have to be 2, 5 to 6? No. It could be 20, 50, or 60. Remember your dilations from geometry, though. The triangle would be a lot bigger, but the angles would be exactly the same. All right, so there it is, law of cosines. Problem number 4 is probably the only one that will give you a bit of a hard time, because it gives you expressions for the different sides. So you'll have expressions here foiling it all out. But the angle is 60 degrees, so it's a nice, well-behaved cosine of 60. We should know that from our unit circle. But other than that, I don't really think that this will, hopefully it won't give you too much of a hard time. So I want you to go ahead and do the assignment now. So do assignment 6G. It's on page 393, and I want you to do problems 1 through 5. Problem 1 is 3 examples, very similar to what we just did. 2, it doesn't give you a diagram, but you have to put the numbers in there, and then find the largest angle. Remember, the largest angle is across from the largest side. Number 3, it gives you the triangle, and it gives you the ratios 3, 2, and 4. Find the smallest angle. The smallest angle would be across from the 4 side. Number 4 is that algebra one that I was talking about. And 5 is a parallelogram. Now remember, in a parallelogram, you've got 2 pairs of congruent triangles, so use that fact when you work with number 5. All right, so that is law of cosines. Very quick little lesson here. So what I would recommend is go do the homework, and then maybe today, the lesson here is 10 to 12 minutes long. Doing the homework should take maybe 15 minutes. Maybe move on to 6H as well. The lesson there is also going to be not quite as long, 12 to 15 minutes, and the homework half an hour to 45 minutes there as well. All right, guys, good luck, and I'll talk to you again soon.